Yes, the general puzzlement that you're filled with is, given that these creatures explore and spread and try out different environments, why did it take hundreds of thousands of years for them to develop complicated society settlements?
That's the first big question. Why did it take so long? And that raises in my mind a hypothesis, a possibility. Maybe it didn't take so long. Maybe things were happening that we haven't yet got hold of in the archaeological record, which await to be discovered. And of course, there are huge parts of the world that have not been studied at all by archaeology. But the fact that huge parts of the world have not been studied at all by archaeology is not on its own enough to suggest that we're missing a chapter in the human story. The reason that I come to that isn't only puzzlement about that 300,000-year gap. It's also to do with the fact that there's common iconography, there's common myths and traditions, and there's common spiritual ideas that are found all around the world. They're found amongst cultures that are geographically distant from one another, and that are also distant from one another in time. They don't necessarily occur at the same time. And this is where I think that archaeology is perhaps desperately needing a history of ideas as well as just a history of things. Because an idea can manifest again and again throughout the human story. So there are particular issues. For example, the notion of the afterlife destiny of the soul. What happens to us when we die? And believe me, when you reach my age, that's something you do think about. What happens? I used to feel immortal when I was in my 40s, but now that I'm 74, I definitely know that I'm not. Well, it would be natural for human beings all around the world to have that same feeling, that same idea. But why would they all decide that what happens to the soul after death is that it makes a leap to the heavens, to the Milky Way, that it makes a journey along the Milky Way, that there it is confronted by challenges, by monsters, by closed gates? The course of the life that person has lived will determine their destiny in that afterlife journey. And this idea, the path of souls, the Milky Way is called the path of souls. It's very strongly found in the Americas, right from South America through Mexico, through into North America, but it's also found in ancient Egypt, in ancient India, in ancient Mesopotamia, the same idea. And I don't feel that can be a coincidence. I feel that what we're looking at is an inheritance of an idea, a legacy that's been passed down from a remote common source to cultures all around the world, and then has taken on a life of its own within those cultures. So the remote common source would explain both the similarities and the differences in the expression of these ideas. The other thing, very puzzling thing, is this sequence of numbers that are a result of the precession of the equinoxes. At least I think that's the best theory to explain them. Here, I think it's important to pay tribute to the work of Giorgio de Santillana and Hertha von Deschend. Giorgio de Santillana was professor of history of science, actually at MIT, where you're based, back in the 60s. And Hertha von Deschend was professor of the history of science at Frankfurt University. And they wrote an immense book in the 1960s called Hamlet's Mill. And Hamlet's Mill differs very strongly from established opinion on the issue of the phenomenon of precession, and I'll explain what precession is in a moment. Generally, it's held that it was the Greeks who discovered the precession, and the dating on that is put back not very far, maybe 2,300 years ago or so. Santillana and von Deschend are pointing out that knowledge of precession is much, much older than that, thousands of years older than that, and they do actually trace it, I think I'm quoting them pretty much correctly, to some almost unbelievable ancestor civilization. Reading that book was one of the several reasons that I got into this mystery in the first place. Okay, now, the precession of the equinoxes, to give it its full name, results from the fact that our planet is the viewing platform from which we observe the stars. And our planet, of course, is rotating on its own axis at roughly 1,000 miles an hour at the equator. But what's less obvious is that it's also wobbling on its axis. And so if you imagine the extended north pole of the Earth pointing up at the sky, in our time, it's pointing at the star Polaris, and that is our pole star. But Polaris has not always been the pole star, precisely because of this wobble on the axis of the Earth. Other stars have occupied the pole position, and sometimes the extended north pole of the Earth points at empty space. There is no pole star. That's one of the obvious results of the wobble on the Earth's axis. The other one is that there are 12 well-known constellations in our time, the 12 constellations of the zodiac, that lie along what is referred to as the path of the sun. The Earth is orbiting the sun, and we are seeing what's behind it, what's in direct line with the sun in our view. And the zodiacal constellations all lie along the path of the sun. So at different times of the year, the sun will rise against the background of a particular zodiacal constellation. Today we live in the age of Pisces, and it's definitely not an accident that the early Christians used the fish as their symbol. This is another area where I differ from archaeology. I think the constellations of the zodiac were recognized as such much earlier than we suppose. Anyway, to get to the point, the key marker of the year, certainly in the northern hemisphere, was the spring equinox. The question was, what constellation is rising behind the sun? What constellation is housing the sun at dawn on the spring equinox? Right now it's Pisces. In another 150 years or so, it'll be Aquarius. We do live in the dawning of the age of Aquarius. Back in the time of the late ancient Egyptians, it was Aries, going back to the time of Ramesses or before. Before that, it was Taurus, and so on and so forth. It's backwards through the zodiac until 12,500 years ago, you come to the age of Leo, when the constellation of Leo houses the sun on the spring equinox. Now, this process unfolds very, 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 very slowly. The whole cycle, and it is a cycle, it repeats itself roughly every 26,000 years. Put a more exact figure on it, 25,920 years. That may be a convention. Some scholars would say it was a bit less than that, a bit more, but you're talking fractions. It's in that area, 25,920 years. And to observe it, you really need more than one human lifetime, because it unfolds very, very slowly at a rate of 1 degree every 72 years. And the parallel that I often give is hold your finger up to the horizon, the distant horizon. The movement in one lifetime in a period of 72 years is about the width of your finger. It's not impossible to notice in a lifetime, but it's difficult. You've got to pass it on. And what seems to have happened is that some ancient culture, the culture that Santillana and von Deschen call some almost unbelievable ancestor culture, worked out the entire process of precession and selected the key numbers of precession, of which the most important number, the governing number, is the number 72. But we also have numbers related to the number 72. 72 plus 36 is 108. 108 divided by 2 is 54. These numbers are also found in mythology all around the world. There were 72 conspirators who were involved in killing the god Osiris in ancient Egypt and nailing him up in a wooden coffer and dumping him in the Nile. There are 432,000 in the Rig Veda. 432,000 is a multiple of 72. At Angkor in Cambodia, for example, you have the bridge to Angkor Thom, and on that bridge you have figures on both sides, sculpted figures, which are holding the body of a serpent. That serpent is Vasuki, and what they're doing is they're churning the Milky Ocean. It's the same metaphor of churning and turning that's defined in the story of Hamlet's mill, of Amlodi's mill. There are 54 on each side. 54 plus 54 is 108. 108 to 72 plus 36. It's a precessional number, according to the work that Santillana and von Deschen did. And the fascination with this number system and its discovery all around the world is one of the puzzles that intrigue me and suggest to me that we are looking at ancestral knowledge that was passed down and probably was passed down from a specific single common source at one time, but then was spread out very, very widely around the world.
So one of the defining ways that you approach the study of human history that I think contrasts with mainstream archaeology is you take this sort of astronomical symbolism and the relationship between humans and the stars very seriously.
I do, as I believe the ancients did.
I think it's important to sort of consider what humans would have thought about back then. Now we have a lot of distractions. We have social media. We can watch videos on YouTube and whatever.
Mm.
But back then, especially before sort of electricity, the stars is like
the
sexiest thing to talk about.
There's no light pollution.
There's no light pollution. So there's the
majesty of the heavens.
Every single night you're spending looking up at the stars. And you can imagine there's a lot of sort of status value to be the guy who's very good at studying the stars and sort of the scientists of the day. And I'm sure there's going to be these geniuses that emerge that are able to do two things. One, tell stories about the gods or whatever based on the stars. And then also, as we'll probably talk about, use the stars practically for navigation, for example.
Oh, yeah.
And so like, it makes sense that the stars had a primal importance for the ideas of the times, for the status, for religious explorations.
It was an ever-present reality.
Yes.
And it was bright, and it was brilliant, and it was full of lights. It's inconceivable that the ancients would not have paid attention to it. It was an overwhelming presence, and that's one of the reasons why I'm really confident that the constellations that we now recognize as the constellations of the zodiac were recognized much earlier, because it's hard to miss when you pay attention to the sky that the sun, over the course of the solar year, is month by month rising against the background of different constellations. And then there's a much longer process, the process of precession, which takes that journey backwards, and where we have a period of 2,160 years for each sign of the zodiac. I think it would have been hard for the ancients to have missed that. They might not have identified the constellations in exactly the same way we do today. That may well be a Babylonian or Greek convention, but that the constellations were there, I think was very clear, and that they were special constellations, unlike other ones higher up in the sky, which were not on the path of the sun, that people paid attention to.
Well, but detecting the precession of the equinox is hard, because especially they don't have any writing systems, they don't have any mathematical systems, so everything is told through words.
Yeah, they have. Let's not underestimate oral traditions. The oral traditions, that's something we've lost in our culture today. It's one of the things that happens with the written word is that you gradually lose your memory. Actually, there's a nice story from ancient Egypt about the god Thoth, the god of wisdom, who is very proud of himself because he has invented writing. Look at this gift, he says to a mythical pharaoh of that time. Look at the gift that I am giving humanity, writing. This is a wonderful thing. It'll enable you to preserve so much that you would otherwise lose. And the pharaoh in this story replies to him, no, you have not given us a wonderful gift. You have destroyed the art of memory. We will forget everything. Words will roam free around the world, not accompanied by any wise advice to set them into context. And actually, that's a very interesting point. And we do know that cultures that still do have oral traditions are able to preserve information for very long periods of time. One thing I think is clear in any time, in any period of history, is human beings love stories. We love great stories. And one way to preserve information is to encode it, embed it in a great story. And so carefully done that actually it doesn't matter whether the storyteller knows that they're passing on that information or not. The story itself is the vehicle, and as long as it's repeated faithfully, the information contained within it will be passed on. And I do think this is part of the story of the preservation of knowledge.
So that's one of the reasons that you take myths seriously?
I take them very seriously, and the other many reasons, but I can't help being deeply impressed and deeply puzzled by the worldwide tradition of a global cataclysm within human memory. I mean, we know scientifically that there have been many, many cataclysms in the past, going back millions of years. I mean, the best known one, of course, is the KPG event, as it's now called, that made the dinosaurs extinct 65 million or 66 million years ago. But has there been such a cataclysm in the lifetime of the human species? Yeah, the Mount Toba eruption about 70,000 years ago was pretty bad. But a global cataclysm, the Younger Dryas, really ticks all the boxes as a worldwide disaster, which definitely involved sea level rise, both at the beginning and at the end of the Younger Dryas. It definitely involved the swallowing up of lands that previously had been above water. And I think it's an excellent candidate for this worldwide tradition of a global cataclysm, of which one of, but not the only, distinguishing characteristics was a flood, an enormous flood, and the submergence of lands that had previously been above water, underwater. The fact that this story is found all around the world suggests to me that the archaeological explanation is, look, people suffer local floods all the time. I mean, as we're talking, there's flooding in Florida, but I don't think anybody in Florida is going to make the mistake of believing that that's a global flood. They know it's local, but that's the argument largely of archaeology dealing with the flood myths, or that some local population experienced a nasty local flooding event, and they decided to say that it affected the whole world. I'm not persuaded by that, particularly since we know there was a nasty epoch, the Younger Dryas, when flooding did occur and when the Earth was subjected to events cataclysmic enough to extinguish entirely the megafauna of the Ice Age.
So there is the Younger Dryas impact hypothesis that provides an explanation of what happened during this period that resulted in such rapid environmental change. So can you explain this hypothesis?
Yes. The Younger Dryas impact hypothesis, YDIH for short, is not a lunatic fringe theory, as its opponents often attempt to write it off. It's the work of more than 60 major scientists, working across many different disciplines, including archaeology and including oceanography as well. They are collectively puzzled by the sudden onset of the Younger Dryas, and by the fact that it is accompanied 12,800 years ago by a distinct layer in the earth. You can see it most clearly at Murray Springs in Arizona, for example. You can see it's about the width of a human hand, and there's a draw there that's been cut by flash flooding at some time, and that draw has revealed the sides of the draw, and you can see the cross section, and in the cross section is this distinct dark layer that runs through the earth. And it contains evidence of wildfires. There's a lot of soot in it. There are also nano-diamonds in it. There is shocked quartz in it. There is quartz that's been melted at temperatures in excess of 2,200 degrees centigrade. There are carbon microspherules. All of these are proxies for some kind of cosmic impact. I talked a moment ago about the extinction of the dinosaurs. Lewis and Walter Alvarez, who made that incredible discovery, initially their discovery was based entirely on impact proxies, just as the Younger Dryas is. There was no crater, and for a long time they were disbelieved because they couldn't produce a crater. But when they finally did produce that deeply buried Chicxulub crater, that's when people started to say, yeah, they have to be right. But they weren't relying on the crater. They were relying on the impact proxies. And they're the same impact proxies that we find in what's called the Younger Dryas boundary layer all around the world. So it's the fact that at the moment when the Earth tips into a radical climate shift, it's been warming up for at least 2,000 years before 12,800 years ago. People at the time must have been feeling a great sense of relief. You know, we've been living through this really cold time, but it's getting better. Things are getting better. And then suddenly around 12,800 years ago, some might say 12,860 years ago, there's a massive global plunge in global temperatures, and the world suddenly gets as cold as it was at the peak of the Ice Age. And it's almost literally overnight. It's very, very, very rapid. Normally, in an epoch when the Earth is going into a freeze, you would not expect sea levels to rise. But there is a sea level rise, a sudden one, right at the beginning of the Younger Dryas. And then you have this long frozen period from 12,800 to 11,600 years ago. And then, equally dramatically and equally suddenly, the Younger Dryas comes to an end, and the world very rapidly warms up, and you have a recognized pulse of meltwater at that time as the last of the glaciers collapse into the sea, called Meltwater Pulse 1b, around about 11,600 years ago. So this is a period which is very tightly defined. It's a period when we know that human populations were grievously disturbed. That's when the so-called Clovis culture of North America vanished entirely from the record during the Younger Dryas, and it's the time when the mammoths and the saber-toothed tigers vanished from the record as well.
Is there a good understanding of what happened geologically, whether there was an impact or not? Like, what explains this huge dip in temperature and then rise in temperature?
The abrupt cessation of the global meridional overturning circulation, of which the Gulf Stream is the best known part. The main theory that's been put forward up to now, and I don't dispute that theory at all, is that the sudden freeze was caused by the cutting off of the Gulf Stream, basically, which is part of the central heating system of our planet. So no wonder it became cold. But what's not really been addressed before is why that happened, why the Gulf Stream was cut, why a sudden pulse of meltwater went into the world ocean, and it was so much of it, and it was so cold that it actually stopped the Gulf Stream in its tracks. And that's where the Younger Dryas impact hypothesis offers a very elegant and very satisfactory solution to the problem. Now, the hypothesis, of course, is broader than that. Amongst the scientists working on it are, for example, Bill Napier, an astrophysicist and astronomer. They have assembled a great deal of evidence which suggests that the culprit in the Younger Dryas impact event or events was what we now call the Taurid meteor stream, which the Earth still passes through twice a year. It's now about 30 million kilometers wide. It takes the Earth a couple of days to pass through it on its orbit. It passed through it in June, and it passes through it at the end of October. The suggestion is that the Taurid meteor stream is the end product of a very large comet that entered the solar system round about 20,000 years ago, came in from the Oort cloud, got trapped by the gravity of the sun, and went into orbit around the sun, an orbit that crossed the orbit of the Earth. However, when it was one object, the likelihood of a collision with the Earth was extremely small. But as it started to do what all comets do, which was to break up into multiple fragments, because these are chunks of rock held together by ice. And as they warm up, they split and disintegrate and break into pieces. As it passed through that, its debris stream became larger and larger and wider and wider. And the theory is that 12,800 years ago, the Earth passed through a particularly dense part of the Taurid meteor stream and was hit by multiple impacts all around the planet, certainly from the west of North America as far east as Syria. And that we are by and large not talking about impacts that would have caused craters, although there certainly were some. We're talking about airbursts. When an object is 100 or 150 meters in diameter and it's coming in very fast into the Earth's atmosphere, it is very unlikely to reach the Earth. It's going to blow up in the sky. And the best known recent example of that is the Tunguska event in Siberia, which took place on the 30th of June, 1908. The Tunguska event was, nobody disputes, it was definitely an airburst of a cometary fragment. And the date is interesting because the 30th of June is the height of the beta Taurids. It's one of the two times when the Earth is going through the Taurid meteor stream. Well, luckily, that part of Siberia wasn't inhabited, but 2,000 square miles of forest were destroyed. If that had happened over a major city, we would all be thinking very hard about objects out of the Taurid meteor stream and about the risk of cosmic impact. So the suggestion is that it wasn't one impact, it wasn't two impacts, it wasn't three impacts, it was hundreds of airbursts all around the planet, coupled with a number of bigger objects, which the scientists working on this think hit the North American ice cap largely. Some of them may also have hit the Northern European ice cap, resulting in that sudden, otherwise unexplained flood of meltwater that went into the world ocean, and caused the cooling that then took place. But this was a disaster for life all over the planet. And it's interesting that one of the sites where they find the Younger Dryas boundary and where they find overwhelming evidence of an airburst and where they find all the shocked quartz, the carbon microspherules, the nano-diamonds, the trinitite, and so on and so forth, all of those impact proxies are found at Abu Hureyra. That was a settlement within 150 miles of Göbekli Tepe, and it was hit 12,800 years ago, and it was obliterated. Interestingly, it was re-inhabited by human beings within probably 5 years, but it was completely obliterated at that time, and it's difficult to imagine that the people who lived in that area would not have been very impressed by what they saw happening, by these massive explosions in the sky and the obliteration of Abu Hureyra. Now, this is a theory. The Younger Dryas impact, it's a hypothesis, actually. It's not even a theory. A theory is, I think, considered a higher level than a hypothesis. That's why it's the Younger Dryas impact hypothesis. And of course, it has many opponents, and there are many who disagree with it. And there have been a series of peer-reviewed papers that have been published supposedly debunking the Younger Dryas impact hypothesis. One, I think, was in 2011. It was called a requiem for the Younger Dryas impact hypothesis. And there's one just been published a few months ago or a year ago, called a complete refutation of the Younger Dryas impact hypothesis, something like that, some lengthy title. So it's a hypothesis that has its opponents. And even within those of us who are looking at the alternative side of history, there are different points of view. Robert Schoch from Boston University, the geologist who demonstrated that the erosion on the Sphinx may well have been caused by exposure to a long period of very heavy rainfall. He doesn't go for the Younger Dryas impact hypothesis. He fully accepts that the Younger Dryas was a global cataclysm and that the extinctions took place, but he thinks it was caused by some kind of massive solar outburst. So what everybody's agreed on is the Younger Dryas was bad, but there is dispute about what caused it. I personally have found the Younger Dryas impact hypothesis to be the most persuasive, which most effectively explains all the evidence.